Hello everyone, we're going to be going over question 5 on assignment 19 at the moment. This question talks about having a galvanic cell that has a zinc anode immersed in a zinc nitrate solution and then a platinum cathode immersed in a sodium chloride solution. So I'm just going to draw out kind of what we're talking about because this is important information for you guys to know anyway for the exam, so on how to do this. So it's pretty much telling us that we have a solution, we have a zinc anode. We're told that that is our anode. I'm going to write that down right now. And that in our solution we have zinc nitrate. So when we say we have zinc nitrate, that means that it's broken down into zinc 2+ and then our nitrate. But our nitrate is really just kind of kicking around. So we'll just kind of put it off to the side. We don't necessarily need it in there. We don't need to pay attention to it. It's really necessary, but on the other side, then you have another electrode, and in this case here now, this is platinum. We're told that that is our cathode, and now, so these guys are connected. This is a voltaic cell or a galvanic cell. Like that for now. Actually, I can explain that. So we know that electrons flow from anode to cathode in galvanic cell. Such. And in the platinum one, we're told that it's immersed in a sodium chloride solution. So in here we have sodium chloride. So that means that we know we have sodium pluses and we have some Cl minuses. We're also told that it's equilibrated with Cl2 gas. So in here we're also going to have Cl2 gas, and that's at 1 atmosphere and 25 degrees Celsius. And of course, you have your little salt bridge, otherwise nothing is going to happen. Just draw that guy in there as such. Okay, so this is the situation in our galvanic cell. The first part of the question says, write a balanced equation for the cell reaction. It means you need to know what's going on at both the anode and the cathode. So for the anode one, write this down. First of all, what is happening in anode? Anode is oxidation. We know we have zinc present in there, and we have zinc 2+ present. It's a matter of figuring out, okay, well, what is the reaction that's actually happening? Well, if it's an oxidation, it has to go from zinc to zinc 2+. And to balance that guy, 2 electrons. Okay. Now, if we look at the cathode, now cathode is reduction. Remember that red cat. So what you have in this solution, you know, you have Cl- ions, and you also have Cl2 gas. So the big question is, what direction is this going in here? You know it has to be a reduction. Look at your oxidation states. So the Cl- -1, Cl2 is 0. So in order for reduction to happen, you're going down in oxidation state. So that means we're going from here to here. Write that out. We have Cl2 going to Cl-. So we want to balance this. We have 2 Cl-. Balance our charge, 2 electrons. We can add these two together now nicely because we have 2 electrons on both sides. Cancel those guys out. We have zinc plus Cl2, 2 Cl-, and zinc 2+. So there is your overall balanced equation. And another thing I want to point out here is how you would go about writing the cell notation for something like this. Remember, you always go anode to cathode, and you're kind of going in the direction that the reaction occurs. So we would have our zinc electrode separated from our zinc 2+. So zinc is being oxidized. This is zinc 2+. And then this is physically separated from the other side of the cell. And in that case, we're going from Cl2 to Cl-. So Cl2 in a different phase, this is a gas phase, from Cl-, which is an aqueous phase. And we also have our electrode, which is platinum, which isn't necessarily participating in the reaction, but it's there to help funnel the electrons. that was just part A. Let's erase this one. Make sure you have all those equations written down. Okay, so part B asks, you have a steady current of 0.8 amps, and this is flowing for a period of 25 minutes. So how much charge is passing through this circuit? So we're looking for Q. And the equation for Q is IT. Now, another way of remembering this is also go by your units. So the units amps are also coulombs per second. And if we can get this in seconds, that's going to give us our charge in coulombs. So I'm going to write out all of this here. You have 0.8 coulombs per second, 25 minutes, and make sure that you change this over into seconds. So our answer in that case should be 1,200 coulombs. So that's part of the question. And the rest of it asks, how many moles of electrons is this charge equivalent to? So this is in coulombs, and you guys know a number that's in a coulomb per mole of electrons. So that's your Faraday, which is 96485 coulombs per mole. So if you want to find out how many moles of electrons we actually have, you can do Q over F in order to get that, because you're going to have 1,200 coulombs over 96485 coulombs per mole of electrons. So in that case there, you should end up with 0.0124 moles of electrons. Now let's move on to part B, or C, sorry, this is part B. Now we're moving on to part C. Hopefully you guys got that. Remember to pause the video if you really need to, okay, or go backward. So part C asks, they want you to calculate the change in mass of the zinc electrodes. Really want to find out what's going on with that mass of the zinc. And the way to do this is to go right back to your original equation with zinc. You know, I already balanced this equation. The zinc is going to zinc 2 plus 2 electrons. So if you know your moles of electrons, you can then figure out moles of zinc. I'm going to do moles zinc, starting from our moles of electrons. And you're just doing stoichiometry here. So you have 2 moles electrons per 1 mole of zinc. So you're going to end up with your moles of zinc. And then once you have moles of zinc in moles, you want to end up getting 2 grams, right? So you're going to then multiply that by your molecular weight of zinc. So your answer in this case here, and I won't go through doing all of the numbers, but you guys should be able to do that, no problem, should be 0.405 grams of zinc. So that's what's changing. And another question is this being generated or consumed? Well, in this case here, it's being consumed because we're losing zinc into zinc 2 plus. Now the next part is part D. It wants to know the volume of gaseous chlorine either generated or consumed from this reaction. So again, you have to go back to your balanced equation for chlorine. And let's do that here. That was our zinc one right there. So our chlorine equation, just quickly balance it here. We had this going on here. So again, you know your moles of electrons, you can find out your moles of chlorine, which just going by the last one that we did with zinc, it was 1 to 2 again. So you know your moles of chlorine is 0.124. Oh, sorry, no, that's your moles of electrons. Your moles of chlorine is going to be 0.124 divided by 2, right? So we could still do that. So we end up with our 6 point, I'm just going to write it out like this instead because we're getting pretty low. That's 10 to the minus 3 moles. Now with this, now you have to get into volume. So remembering our PV equals nRT. So if we want to find volume, then the only place to get mixed up here is just with your units. So pay attention, you know you have your moles. We have our temperature, which is going to be 298 Kelvin, so 25 degrees Celsius. Your pressure is given in atmosphere. You know that is 1 atmosphere. And so you have to think about which R you're going to use. So if we use 8.314, that's the joules per mole. That's going to be pascals meter cubed. So in this case, we don't want that. You want to use little r's, 0.08206, and that's liter atmospheres per mole Kelvin. So in the end, your volume should be, you're going to get it in liters, so I'm just switching it to mils right now, 152 mils, and that is consumed because you're using up the chlorine gas and generating chlorine ions, or chloride.